When SSRCx performs new construction commissioning and lead commissioning, their three-phase approach gets building systems operational and functioning to their full capacity. SSRCx also performs retro-commissioning by optimizing an occupied building systems to meet the occupant and owner's needs. SSRCx is also just one of a few companies in the world licensed to provide continuous commissioning services. By optimizing HVAC system operations for existing conditions and providing ongoing monitoring of energy usage, continuous commissioning provides owners with the best performance at the best cost. SSRCx also provides building enclosure commissioning to look at moisture control, air leakage, and energy performance. SSRCx, Smith Seckman Reed's commissioning division.
Hey everybody, welcome to CxEnergy 2021. Hello Rebecca, how are you?
Hey Kevin, how are you?
Good, doing well. Trying to keep it together.
Are you ready to talk about low voltage?
Yes ma'am, ready as I'll ever be.
So today we're going to be talking about commissioning integrated low voltage systems in healthcare. My name is Rebecca Richardson. I am an EIT with SSR Commissioning, and I am currently in Kansas City. So going through our learning objectives for this presentation, we're going to be providing you with a brief understanding of the common basic low voltage system configurations and typical testing protocols for those systems. We're going to stay pretty surface level, just providing a brief understanding. We're not going to be diving into our testing procedures. We're also going to be talking about the importance of advocating for clients' needs and unique considerations during commissioning of those low voltage systems. We'll talk about commissioning coordination difficulties that are unique to commissioning multiple integrated systems. And we'll talk about commissioning low voltage system issues and strategies to mitigate their effect on the commissioning process. So for this session, low voltage systems will include nurse call, fire alarm, lighting control, security/access control, and RTLS. Sorry, IT folks, we're not going to be talking about structured cabling infrastructure today.
Hi, my name is Seckman Reed, and I am in beautiful Memphis, Tennessee. As I'm sure everyone here understands, I know Rebecca does, but I bet anybody else who's watching a presentation like this understands it as well, but building systems are complicated. And even the simplest low voltage designs are going to typically require at least some degree of interoperability between otherwise discrete systems. Ever since the 80s or early 90s, whenever it was that we started using DDC controls, the use of software versus hardware to integrate these systems has become near universal. There's a lot of near continuous advancement in the field, and it's freed up designers to improve building performance with progressively complex sequences between way more systems than was feasible even just 10 years ago. So understanding that, we also know that installing and configuring these systems has grown a lot more complicated as well. Construction, especially a big hospital, has a lot of independent stakeholders, specialized trades, and poor communication between those entities or ineffective communication between the design team and the construction team can result in systems that just don't perform per design intent. And that's where we come in. That's what the commissioning process is for.
Many of you will recognize this excerpt from ASHRAE Guideline 0. This is a quality-focused process for enhancing the delivery of a project. The process focuses on verifying and documenting that all of the commissioned systems and assemblies are planned, designed, installed, tested, operated, and maintained to meet the OPR. Hopefully that's the last reading of notes I'll do today. So how does this apply in a practical way? This system no one verifies that an integrated system really works the way it's supposed to, except for the commissioning agent. Do you agree?
Oh, yes. Yes, I do. It might not technically be true. Some listener may send us an email about it, maybe. But in my experience, the design, like everybody does their job, but the designers are going to design the system and set the parameters and define the requirements and system capacities and functionalities and features. But it's less likely that the design team is going to show up on a job site and formally test a system to make sure it actually does what they designed it to do.
Yeah, from my experience, the design team specifies requirements, but only rarely confirm that compliance through testing. The trade subcontractors, they're skilled professionals, but they usually just test their own installed equipment. They might not look at that gray area as much between the trades where integration lives. AHJs, they're looking at code and life safety compliance with little concern for the OPR's requirements. When each trade says that they're done and the work's passed AHJ inspection, it's usually the commissioning agent who reveals those significant deficiencies through our functional testing of an entire integrated system. Today, we're going to discuss the application of the commissioning process to low voltage systems and their integrations as they are commonly found in healthcare occupancies. So our first low voltage system that we'll be talking about today is fire alarm. Fire alarm systems are a series of devices that work on people through both visual and audible notification when smoke and fire emergencies are present. So initiation devices are heat and smoke detectors, manual pull stations, and sprinkler flow and tamper devices. When initiated, either using heat or smoke or a magnet sometimes, when they are initiated, the notification devices throughout the hospital will go off. That includes visual strobes and audible horns. So hopefully, when you initiate those devices, the strobes will all be synchronized. They'll be going off throughout the hospital. They'll be heard throughout the hospital. Some spots might be quieter than others, but those are the nice spots. The fire alarm control panel during initiation will receive any information about what type of device went off, as well as providing information of what that device number is, and again, kind of where it is in the hospital. To test that fire alarm control panel, we make sure that those device locations are reading out correctly. We perform a test through the PA system, making sure that it's able to be heard throughout the hospital. And we do a battery test, making sure that the batteries of that fire alarm control panel are able to tide a power outage. You want to make sure that your fire alarm system is going to operate even in power outages, even in any sort of power emergency. So we have some notification requirements provided in the NFPA 101 that apply specifically to healthcare. There are some unique caveats in the healthcare industry, and the NFPA has addressed. Smoke detectors that are used to automatically open doors must sound an evacuation alarm, where other occupancies are granted an exception to that. You have the caveat of notification devices in critical, they're permitted to be visual only, making sure that you're not alerting babies or very critically injured patients of issues. Then also initiation devices for kitchen areas are not required to trigger building-wide notification in hospitals. NFPA 101 18.3.4.4 requires emergency control functions to be automatic, where they might not be in other occupancies. This means releasing hold open devices for doors or other operating opening protectives, stairwell and elevator shaft pressurization, anything that's going to keep smoke in its own spot or be able to get it out of the building as quickly as possible is important for healthcare facilities. That includes smoke management, smoke compartment, HVAC shutdown. Unlocking doors is important to provide egress. Elevator recall and shutdown, while not specifically fire alarm, is also part of this automatic emergency control.
And lighting control systems can be unique in the healthcare environment too. Now, a typical run-of-the-mill lighting control system, it's going to be occupancy sensors, vacancy sensors, daylight harvesting systems, and scheduled events. Where the time of day, it's either got an astronomic time clock or just a photo cell or both. But normally it's about timing. Generally, what we're testing is timing, and we'll look at some more advanced stuff a bit later on. But like circadian lighting, it's not really an integrated system, so we won't address it later. But it's a complicated lighting control scheme that a lot of healthcare environments use, where the light level, just the intensity of the light, and the spectrum and the color temperature and your cumulative daily exposure are all tracked very carefully and controlled and managed for the benefit of patients and staff. And in those instances, that's where there'll be a lot of Q&A on the site. You may not have enough information in the design to really test the system and make sure that it works. So that's a cooperative one. There'll be a lot of interaction with the technician. And a lot of facilities for healthcare also include research. And research means there might be animal holding spaces or a vivarium. And those areas where they're not very hard to test, but it can be a complicated sequence for the lighting control, because they'll have 20 or 50 little rooms that are 10 by 10 where the animals live. And each one of them may have its own seemingly independent lighting control system. It generally isn't, they'll be centralized, but each one is individually programmed depending on what research is being done, what the day-night cycle of the animal being tested in a given room is, or what they want it to be. So it has a lot of different variables, but it's also very, very important that it be right. It's a sensitive topic. If it doesn't work, if the lighting control system is off and doesn't perform the way it's supposed to, it could harm the animals. It could endanger ongoing research. It could make people start over. It could jeopardize grant funding. So it needs to be tested very, very carefully.
Mm-hmm.
How about nurse call?
Something that's a little bit more simple, nurse call, is basically just communication between patients and nurses and staff. So that communication is used for assistance. It's used for a quick remote communication, and it can be used for emergency events. Things such as basic needs can be met by hitting the water button or the toilet alarm. Healthcare now is all about comfort of patients, and while it's not quite a BR or bed and breakfast, it is essential to provide these basic needs to the patient. So there are basic alarms in the nurse call system for water, toilet, basic assistance, making sure that the TV remote works. Then there's also two-way communication between the nurse station and the patient station. This can be used for instruction, wondering if the patient's wondering when the next doctor visit will be, the nurse is able to provide that information without having to walk to the patient room. For critical alerts, coding emergencies, the nurse call system is used to signal every nurse in the zone that there is a coding emergency going on, so that multiple staff can be there to provide assistance as needed. We test nurse call system by initiating each alarm. We verify that the zone lights are responding with the correct color. We're verifying that the nurse station has the correct address location and the right type of alarm. We don't want them thinking a code blue is going on when a patient's just asking for water. Then we also are looking at the nurses' stations. We want to make sure that you can communicate clearly to your patient station, that both at the nurse station and the patient station, they can hear clearly and everything is able to be heard and understood by both sides. Access control is the control of entrance into different areas of the hospital. It also involves the CCTV camera system for real-time visuals and incident reporting, all of this being stored in history. Card readers, biometrics, these are all things that can help grant access into spaces, and all of the card reader information is recorded at head end, so they're able to see who's going where, from what room to what room. Any information is stored at head end. The CCTV system, we test to make sure that clear visuals are being shown. For cameras that are able to rotate or zoom, we make sure that those features are still clear and that they're consistent throughout the hospital. I was just testing CCTV a couple weeks ago, and we were making sure that we could track a target throughout the hospital.
Was it you?
It might have been incidents such as holdopens or forced entries on doors is sending an alarm to the head end. We're making sure that that alarm goes through, again, that the right door location is being recorded, and that the history is able to be pulled up for that person, for that card going throughout the hospital. We tested each door with one person at the head end, one person at each door. Whoever has to walk the most is the person at each door. And we're checking location readouts and all that information that I talked about earlier. Real-time locating systems allows patients, staff, and equipment locations to be known at all times while in the hospital. Kevin, I think you've done a little bit more testing about this recently, so if you want to talk about it.
Sure, I'll take this one. So real-time location systems are, everybody knows what an RFID chip is by now, but in any case, it's a little object that sends or receives a signal, and they're cheap, and people are beginning to use them in very effective ways. For example, wander management systems. If you're in a memory loss treatment or behavioral health issue where you might have a wandering patient, they have their little tag that says, "Hi, my name is," and if they're wandering around the facility and they end up approaching a place they're not supposed to be, or they're approaching the envelope of the place where they are supposed to be, it'll either lock or fail to unlock doors to let them get into places where they're not supposed to be, or where it would be unsafe for them to be, or disorienting for them to be. And there'll often be a fairly rapid response. They'll integrate with the nurse call system or a security system, so that when a person is inhibited from proceeding by a wander management system, they'll almost immediately be greeted by a staff member who can take their hand and help them back in a trauma-free way that's not confusing to get them back where they're supposed to be. And infant abduction systems are very similar to that too. But of course, you're not dealing with, you're dealing with an infant is who you're protecting. And so it's not someone who's ambulatory on their own. And they'll have either single or multiple criteria, like if the infant will be wearing an RFID bracelet or something like that. And if that RFID chip, if an infant tag approaches a door and it doesn't have the corresponding parent tag in the vicinity, or a staff tag in the vicinity, then it either won't unlock a door, or it will lock a door that's normally open. Mm-hmm. And they do the same thing for asset management, like just equipment. It's not really a patient safety thing, it's just you've got all this equipment, especially in healthcare, that's on little mobile dollies that get better and better and better, and it'll have a little tag on it so people can track it throughout the campus and make sure they know where it is and the right person has it, things like that.
Yeah, and RTLS systems are generally specific to the hospitals. So when we're testing those, we make sure that we have the technician with us. We're making sure that at the head end, they've got all the information they need about who and where, everything that you kind of have in security as well. And we use the tools that staff would use after turnover. So if they've got mobile devices or something, we'd want to make sure that we could see what the staff will see, make sure that what they're getting is clear and consistent data as well.
Yeah. Well, so now we've talked a little bit about these systems in their most basic iterations. But what about when more complex integration is required, which is really what we're talking about. If you're commissioning a major hospital project, those same systems are not necessarily going to be very basic. They're going to be integrated, and it may be complicated. So back to fire alarm. The integration with fire alarm, it can be simple, it can be complicated. If there's multiple buildings on a campus, then each building may have its own fire alarm control panel. Each may act fairly discreetly as its own fire alarm system, but those control panels are still going to talk. There's going to be pipe and wire between the buildings. There might be different alarm conditions. There might be different announcements based on what building you're in and what building there's an event. One building might go into general alarm and do a voice announcement that there's a fire in the building. And the adjacent buildings might just throw a supervisory, or it might have some version of an abbreviated general alarm and an announcement saying there's been an emergency on the campus. And then buildings that are 2 buildings away, it might only be a supervisory signal and no alarm that the occupants are aware of, except someone who's monitoring the control panel or the security system. Elevator recall is an integration. That's if it's a hospital and there's an elevator and there's a fire alarm system, there's going to be elevator recall. HVAC integration, that can be really, really simple, small facilities that don't have a whole lot of mechanical systems. It might just be a shutdown. If the fire alarm goes into general alarm, send the signal, and all the air handlers shut down, and that's it. But in others, you have stairwell pressurization, you have smoke evacuation systems, you have smoke compartmentalization, or even if you don't have those, even just a more complex HVAC sequence of operations, where instead of just shutting down all the air handlers, it might set all the chillers to 50%. It might close this damper. It might open these other dampers. It might reduce, it might turn off some air handlers, but turn others on, and ramp that VFD all the way up so that it's rocking. There's also going to be access control integration. You have the path of egress at a minimum. When the fire alarm system goes into general alarm, the access control system is going to have to unlock doors that are in the path of egress. You can't have anybody stuck just because they don't have a badge that'll open a door to the closest exit to the building. So we have, oh, I can't remember who it was. We have a coworker who
Tim Gallagher.
recently, was it Tim? We just had somebody who recently tested a fire alarm system in a major airport, and the egress system worked, the path of egress unlocked, but it included opening doors that would let flyers just walk out of the concourse and onto the tarmac and out to the exterior of the gate, walk around the taxiway, which of course was not the intent. That's a sensitive security area, but it's also not the safest place in the world to just turn civilians loose.
That might be more dangerous than a fire building.
Right. Yeah, depending on how busy it was at the airport, it might be safer to fight the fire. And there's also lighting control integration. It's become increasingly common for fire alarm systems to talk to lighting control. When there's a general alarm, all the lights that have been dimmed automatically or by end users in their offices, or scheduled lighting that's down low because it's in the middle of the night. But if the fire alarm goes off, all of those are going to ramp up to 100%. And then you'll also integrate your kitchen fire alarm systems and ANSL systems, just so that the fire alarm control panel is aware of what's happening in the kitchen, whether or not a fire or smoke event in the kitchen triggers a general alarm. building-wide.
Yeah. Moving on to security, integrated access control adds more testable features and scenarios. So instead of just having card readers, you have multi-credential rooms where you have to enter with card and biometric scanners. There's also the anti-tailgating piggybacking feature, where most commonly in prisons and airports, but also in hospitals, in maybe some higher restricted spaces where you want to make sure that you know who's in that building, who's in that area.
Right, the opioid closet in the pharmacy.
Yeah, pharmacy's big one. You want to make sure that people are, you're only having one person at a time. So there's systems with optical turnstiles, CCTV, other systems that are able to detect multiple individuals and keep it down to one person per entry. You've got integration of access control with infant abduction and wander management. In the event that you have infant abduction, you can create a man trap where the person who's taken the infant can be restrained to a small area for security to come and work out what's happening and what's gone wrong and how to resolve the issue in a calm and simple manner. You also have that asset management and equipment tagging, being able to prevent an otherwise valid credential from unlocking a door if there's also an item or a piece of equipment that's present. So this can help.
I've still got my nurse call remote in my pocket. I go to leave, and maybe that door isn't going to unlock because they're both right there. Yeah.
Exactly. Yeah, helping from accidental loss or theft situations from occurring. There's also integrated lighting control where you have, so generally we commission lighting control to conserve energy usage. We're looking at lead requirements through occupancy and vacancy sensors, daylight harvesting, scheduled events, that kind of thing. Healthcare occupancies can present challenges and opportunities to be a good advocate for clients. So lighting control can integrate with nurse call, making sure that spaces are dimmed in the evening hours to keep patients allowed to rest and create that calmer environment. And that's a little bit of buildup on their circadian lighting that we were talking about. Being able to have the indoor lighting simulate what the outside lighting is doing to maintain good schedules for the patients and nurses, where otherwise it would just be daylight 24/7 to them, and it might be hard to go back at the end of the day and rest, or as a patient be able to have it dark enough for you to be able to go to sleep. There's also, for seizure situations, you can have the rooms dim all the way down so that the seizure patient is able to get more comfortable and not have a bunch of blinding lights in their face. But you can still have it set up so that one light is on for whatever nurse or doctor is on site to help that seizure patient. We also, in integrated lighting control, have integration with mechanical systems. So healthcare facilities, they put a high demand on mechanical systems. In an effort to gain efficiency, a lot of designs will integrate networked lighting controls with HVAC to reset local temperature and airflow set points based on whether a space is occupied or vacant. Even if this integration isn't in scope, it's good coordination to test this integration, and it can put you in a position to at least spot check the integration during lighting control functional testing and inform the client of any issues or inconsistencies with that integration. Moving on, Kevin, can you see me all right?
Yeah, I can see you very well. Can you see me okay?
It looks a little fuzzy on mine. That might be a result of doing this over a couple thousand miles. But
how about you guys in the audience? Can you see us okay? Just kidding. Please don't respond.
Moving on to nurse call integration, that tagging system that we talked about with RTLS is able to be integrated pretty seamlessly with Nurse Call. So based on location, you can have activation of nurses. So if a nurse is in a zone, regardless of if they should be in that zone or not, if the code blue goes off in that zone, the nurse is able to go assist since they are one of the closest people to the room. Those integrations can also go through mobile alerts. They can go through VoIP, text, even email, to make sure that the nearest person is available. Any nurse call situations are reported back to whoever needs to know. If a doctor has been assigned to these 4 patient rooms, they're able to get any nurse call alarms or information that comes through sent straight to their phone through text or email. Moving on to RTLS.
Yeah, so we've spent some time talking about this, Rebecca, but there's some details that need to be brought to bear just so everybody has a better understanding of some of the things that a healthcare occupancy presents with these systems. So an infant abduction system is, while it's really just, it's almost a glorified access control system that just might use multiple conditions, like the presence of a parent tag and an infant tag, or the door won't open. But there has to be some kind of communication with the fire alarm system, because if I just grabbed a baby and I'm trying to leave and I come to a door I can't open, well, but there's a pull station, I'll just set off the fire alarm. By code, that has to, you have to give me egress. So working with the AHJs, a lot of facilities will set up specialized fire alarm zones, like just the maternity ward. And within that zone, they'll be allowed to have delayed egress on fire alarm rather than immediate egress. And so there might, depending on what the AHJ is comfortable with and what arrangement they come to with the owner and designer, it might be 15 or 30 seconds where I've stolen a baby, I came to a locked door, I pull the fire alarm and I push the door, but the door is still not going to unlock for 15 or 30 seconds, maybe something like that. And the intent there is that in that window of time, let's say that 15 seconds, before that door unlocks and lets me go through, that a staff member is going to come in and talk to me and say, hey, what's your name again? I forgot about you. How's it going? And who's this? And kind of, let's get to the bottom of the situation, because there will be a window of time. And outside that window, that door is likely to open and let the person out. And elevator integration, infant abduction systems will independently integrate with elevator systems, similar to the way that fire alarms do, except it won't trigger a recall. It'll trigger, I think the last technician I talked with about it called it a lockout, where the elevator's there and the buttons work and everything. But if you've got a baby you're not supposed to have with you, the door's just never going to open. It's never, the elevator system is going to know that we're in an infant abduction alert, and the elevator is not going to let anybody into it.
Yeah, there's also integration with infant and nurse call, where the nurse call system can put up pink zone lights for nurses and doctors to be able to know that there is an infant abduction situation going on. It's a discreet way of showing everyone, staff, that an infant abduction situation is going on so that they can help assist in that emergency.
Yeah.
So while most low voltage systems don't have codes, they're kind of based on what the client wants, what the owner wants, and best practices. Fire alarm does have a lot of great guidelines in the NFPA 3 and NFPA 4 towards commissioning integrations between fire protection and life safety systems. They provide a guide making sure that you have SOOs for integrated systems, that there's compatibility of data sharing systems like BAS. NFP4 provides minimum requirements for testing integrated fire protection and life safety systems. So they can provide a great guideline, they're not going to have every information. Integrations are still new. They're still very diverse between different facilities. But having a base guideline is important. Moving on to our next learning objective, we're going to start talking about advocating for the client's needs. As a third-party liaison, commissioning authorities need a great understanding of all the systems for key elements of a successful project. This often presents opportunities to be an active advocate for our clients. Prior to the design process, the client will develop their owner project requirements, OPRs. They are used to meet the client-specific needs. They might not be code or design-based, but they are necessary for that facility. During design review, the commissioning agent can suggest sequence of operation revisions that might be more beneficial to the owner. During the construction phase, the commissioning agent might discover installations that are not per design, but may choose to advocate for those, for acceptance of those as the superior configuration.
I've done it.
As the client's advocate, looking for ways to bring additional value to the commissioning process is important. Where feasible, it's good to encourage the O&M staff to attend testing for additional information on how their system works. Being able to see something going on in real life is going to be infinitely more valuable than just sitting there and learning about it during training day. Talking with clients about the needs of their end users might inform areas of special concern. Out of scope observations, we like to follow the see something, say something mindset, that we might be walking the site and we might see something that isn't in scope, but it is a code violation, or it is something that could be a concern future on for the client. It's understood in our industry generally that we're serving to improve the building performance. The practical reality is that, like everyone else, commissioning providers are businesses. We can't make a habit of working for free. But we are contracted to we may be contracted to only commission the lighting control system. So that's what we're going to do. But that said, there are real benefits to keeping your eyes open while on site, keeping the client informed about out-of-scope systems. Do you agree?
Yes, absolutely. And I do it regularly. It doesn't, of course, again, we're not advocating that anybody do a lot of free work or get involved in areas of the project that are not, that aren't our purview. Mm-hmm. But I mean, if we find something significant, if you're just walking around, it's not going to take any time when you're walking. Just look around, and if you see something that you know personally, like that's wrong, I bet they want to know about that. Whether or not it's in your scope, it might behoove you to at least mention it, start a conversation about it.
Yeah, and especially with so many integrations going on now, something that affects the nurse call system might end up affecting your access control testing.
Yeah,
so making sure that the whole is improved is going to help with that broader goal of having a fully working hospital.
Yeah, that's true. And then
secondly,
go ahead.
You go ahead.
Okay, so there's the broad, we're supposed to be improving the delivery of this facility. So anything that we see and bring up, by definition, is an improvement, whether it's technically in our contract to observe that or not. But there's also kind of a selfish benefit in there too. When a commissioning authority on the job discovers or resolves or otherwise brings to the table any significant issue that was found, that's good enough as it is on its face for building the relationship with the client. But if it's something that's not in your scope, that goes a long way toward convincing the clients that you are their advocate and that you represent them and that you're there to protect them and their facility and their patients and their budget. And that level of confidence in the relationship can It can lead to additional work in the future. It can be the difference between, yeah, they did their job and she really went out of her way to take care of us on the last one. And I definitely want her on the next one in 2 years when we build this next building. So that kind of attention to your client in making clear that you're not just looking at the contract and like, nope, you're not paying us to look at that. I'm not looking at it. It's good for everybody to just keep your eyes open. And if you see something, say something.
Another situation about advocating for the client's needs, you might be asked at some point by the client how they could approach a problem or provide input during a decision-making process. The deeper your knowledge as a commissioning agent and your experience with the system client and the construction team, knowing code and design requirements are great, as well as best practices and deployments in similar facilities that can demonstrate the well-rounded expertise that you have as a commissioning agent. While the value of our grasp of these systems and how to test them is pretty obvious, a well-prepared commissioning agent also knows from experience that coordination problems can sink a site visit. We want to work with the construction team in advance to limit that likelihood and have a plan to mitigate delays and other issues with the commissioning plan and maintain value to the client. Another way that we advocate for the client's needs is providing a commissioning plan. It's a very important document. It can be used as a record of the initial commissioning and performance baselines that their system has. It can be used as a guide for future testing by the O&M staff. They don't have to build their own testing procedure. It's already been laid out for them and tested and confirmed to work with their system. It is a source of record for how the building is intended to function. They know what it used to be. They might have tweaks along the way. BAS values might be plus or minus based on the summer or the winter temperatures, but they know when they get back to those same months what their building is supposed to do, how to make sure that it's optimized for energy usage and for the needs of their staff and patients. The commissioning document can be beneficial even after renovations. It can be a guide for life safety SOOs. Just a guide, it might not be applicable after renovations, but it's still, at the end of the day, life safety information doesn't change as quickly as your hospital might.
Yeah. So a minute ago, you mentioned coordination difficulties. I'd like to take a minute and go into that. I know that everybody's experienced them. I imagine if I was in the room, I'd probably hear some chuckles as I go through some of these. But okay, everybody all at once. What's the big one? Completion of systems prior to testing. So the construction team, individual members of the team, or the individual trades, Division 26, Division 23, Division 28, they all have detailed knowledge of their own trades, but they might have limited understanding of other trade systems. And importantly, they may not even have a solid understanding of the sequence of the commissioning process, which is definitely that's an issue on us as commissioning authorities. And I'd be lying if I said that I've never dug myself into that hole. But those misunderstandings, if not carefully managed by the commissioning authority, can cause these knowledge gaps that result in coordination problems. One of the big ones is out of trade system coordination. So all these low voltage systems in a hospital, and they interact with mechanical systems and electrical systems and fire protection systems and nurse call and lighting and all of these things. And the technical details of those integrations can sometimes get lost between the trades just on the construction site. And it can result in scope gaps and incomplete work where everyone thinks it's already done. You know, like the electrical has done their part, they've done exactly what it shows on the drawings, and controls has done their part, exactly what it says on the drawings, and mechanical can do their part, and everybody can do their part as it's shown on the drawings. yet it still doesn't work the way it's supposed to work in the end when all of those different pieces of the puzzle work together. There's also some dependencies that we require, but it might not be clear to the general contractor. That's another area where good communication from the commissioning provider or the CXA as an individual, just keep everybody on the same page and have conversations about it. Like the GC might tell you that the fire alarm system is ready for functional testing, but does the GC understand that for me to do the fire alarm system, access control needs to be complete, or at least complete enough that unlocking of doors in the path of egress can be demonstrated for commissioning of the fire alarm system? And can the access control system be completed to that degree if the infant abduction system is not yet complete?
Yeah. Is it really done if its integrations have not been completed yet?
Right, and a lot of people may not know, and they definitely won't know if you, as a commissioning authority, aren't having detailed conversations with them all along the way, so that the expectations are known and they know what the dependencies are.
Mm-hmm.
Scheduling, of course, is a huge one. This is one I imagine I probably got some eye rolls on that one. Sometimes the GC will schedule fire alarm testing and you show up to do it and you see the fire marshal and you say, huh, and you text the GC and say, hey, I'm here. And they're like, oh, go meet the fire marshal. You're going to do it at the same time. Well, that might sound great to the GC, but probably because the commissioning authority hasn't talked to them and made clear that that's not an optimal situation. You either end up, there's a lot of overlap between what the commissioning authority is going to look at for fire alarm and what the AHJ is going to look at for fire alarm, but it's not equal overlap. Even when we're looking at exactly the same things, it might be to different levels of detail. It might be different. The way that the fire marshal looks at it might be different than the way we expect to look at it. And so when that happens, you're either in this unenviable position of just walking around with the fire marshal and checking what commissioning boxes you can, and then sitting around for a couple hours waiting for the fire marshal to wrap up and leave when you can start over, which of course is not fantastic.
Most situations that I find myself in with that are you walk around with the HJ and you're doing a full day of testing with the HJ and the fire alarm guy. And then the HJ leaves at a reasonable hour and you're stuck there for 3 or 4 more hours with the fire alarm guy doing everything that wasn't covered.
Yeah, and who they gotta blame?
Us, probably.
Yeah.
Yeah, the GC is scheduling functional testing with who they think is a competent person instead of the installing technician is also a coordination difficulty that we find. You, as the client, are going to want a competent commissioning agent that knows things, that is experienced with all these systems, that can tell you code references and design references. We're the same way. We want a technician who knows their system, knows what to do in the event of an emergency, if it's fire alarm or if other things are going on in the hospital and we need to stop right away. We want to make sure that the technician knows how to back out successfully and easily. We want someone who's able to information like device locations. We can't be reading our map trying to figure out where everything is all the time. We want somebody who can resolve deficiencies for us, who can handle those emergencies, like I said before, detailed questions. Sometimes the design might not have quote unquote exactly what the fire alarm guy did to the SOO. The only person who's going to know that is the one who installed the system. And if we can have that person on site, generally functional testing goes a lot smoother. There's a lot more detail in our plan, and overall we provide
and all of these issues can be handled by a good CXA who has good communication habits, and a good relationship with the construction team, including the sub. I know, like, technically our relationship is with the general contractor, but let's be real here. Having relationships with the installers, Division 20 controls technician, that'll go a long way on the coordination front of just making sure everybody's on the same page and you're not seen as the enemy, and that you're not the last person who's going to get told about change orders and schedule changes. And it's kind of like staying in their face a little bit. And it might seem a little uncomfortable to keep dinging them, but staying on the radar and staying in conversation with them is really important toward avoiding these coordination problems later on.
Yeah. So we have coordination difficulties. We also have issues, things that appear on our issues list at the end of a project. There's some common low voltage integration issues that we'd like to talk about briefly here. So some things, just low voltage systems on their own. Space naming is a big thing that changes, especially in healthcare.
Yeah.
There's so many situations where, yeah, I don't know why, but you have one thing on the designs and you have another thing as the wayfinding numbers on the rooms. And that wayfinding number will change 2 or 3 times right there at the end of the project.
After all the doors have been labeled, after the access control system's been programmed with addresses, after some poor electrical assistant project manager has arranged for 700 panel schedules to be printed in hard copy and installed in the panels. I don't know why they always change the room names, but they sure do. Look for that one. It's funny till it's not.
Yeah. Another issue is boilerplate design not being reflected in reality. That's why as-built documentation is such a big thing. At the end of the day, design might not work when you've got HVAC crossing over conduit, crossing over something else, and they might have to change locations of devices.
Or a subcontractor or a subcom. Sorry to interrupt, Rebecca, but some specialty subcontractors, like the access control people or the nurse call people, when you show up to look at to test one of these systems, you may immediately find that it's very different than what you were expecting. It's worth a conversation with the technician, though, because a lot of times those installers and those vendors, they have a relationship with the owner, your client generally, where, you know, I've had technicians who are like, I know it says that, I tried to get them to change it, but I've been doing the lighting control on this campus for 16 years, and I promise you they don't want that. I've put it in the way they want it. I'll check with Billy and see, but this is going to be right. And a lot of times they're right. It's worth listening to them.
Yeah, at the end of the day, they might have the owner's needs in mind where the design might have left that out. Another issue that I see often are parts that have been installed that are programmed, they should be operating correctly, but you get there and magically when the commissioning agent is on site, nothing's operating. We've had so many situations where subcontractors will be, yeah, we just tested it last week. Everything's perfect, 100% good to go. Then we get on site and magically this occupancy sensor isn't working anymore. And that might be a bad product. It might be that installation got missed. But that's a common issue that we see where what they say or what we expected when we got on field was not what was in reality.
So how about integration issues?
So some integration issues, integration with systems not in scope or areas not in scope. When we get down to doing big integrated systems such as black site tests or emergency power systems tests, we're looking at the whole facility, but we might only have lighting control. We might not be looking at the IT techs. We're talking about you guys again. So we might not have IT data center in our spec, in our scope. We might not be looking at it personally, but we definitely want to make sure that that equipment is handled while we're testing the system. Our testing might affect them, and we want to make sure that any testing that we're doing is being covered by somebody. So we might not be able to coordinate that, but we can definitely mention it to the client or to the GC and guarantee that somebody will be on site looking at these things outside of our scope. That also relates to situations where like O&M staff might want to be on site. They get a good feel for what their systems are doing that we might not see. So like the MRI machines, CAT scans, they might be affected by our testing, but we aren't knowledgeable enough about that piece of equipment to be able to make sure that it's working during a black site test. And having somebody on site who has the know-how to deal with those situations can be very important, even if it's not in our scope.
So how can we mitigate?
Sorry,
I stepped on you.
Yeah. I also wanted to talk about the responsible installer. Sometimes they're not well defined and some work can be left unfinished. So I think you mentioned that earlier, how nurse call and other low voltage systems can be done, but VAS guys haven't been notified that they're ready. So that gray area has not been completed yet.
Most done, but everybody thinks somebody else is doing that last termination. And we can help with that. Sometimes like a good GC will recognize pretty quickly that there's a gap there and will sit all the players down and have a conversation and decide who's going to do it. But whether or not that happens, the CXA can help do that too. And when you start seeing blind spots in the integration, just keep talking to people, talk to the GC, talk to the installers, go have lunch with the mechanical PM, and you can get to the bottom of it and facilitate it getting taken care of without too much skin in the game, really.
Yeah, we've talked about a bunch of issues, but haven't really given solutions to those issues. So now we're going to switch over to mitigating the impact of those issues. Getting an early communication with the contractors is a good way to start that ball rolling. So usually commissioning agents will perform a kickoff meeting early on before any equipment has arrived on site, sometimes during steel phase, commissioning on that project. Making sure they understand what the commissioning process looks like, how each subcontractor is involved in that testing. Sometimes electrical contractors don't realize that they'll be needed for a day to do lighting control testing. Getting that information out there as soon as possible and often as possible can help with those early communication issues and flukes. Another way that we can start mitigating those issues early is by performing functionally ready to be tested. We go on site and we make sure that equipment is getting installed correctly. That can look as simple as making sure everything's been mounted in place. It can be as technical as making sure the right part number has arrived, that each part number is documented along with the voltage, current, other information of that part, whether it be a panel or a transformer or whatever, making sure that the people who are actually on site recognize you as the commissioning agent and know that when you're coming later, you'll be looking at these equipment that you're looking at early again, but you'll be testing the functional aspects of them. Another way we can mitigate issues is by developing cooperative relationships with the construction team. Having that good level of respect and trust between the contractors and the commissioning agents is critical for making sure that everybody's aware of any issues that come up if they get some parts that are put on back order and they aren't going to arrive in time for commissioning. Letting the commissioning agents know, hey, we're not going to be ready, can we move it back a week, is important for everybody to make sure that we're not wasting time and effort.
I agree, and that teamwork kind of approach is it's so helpful in the very tangible ways that Rebecca's just described, but also just you want to avoid being the person who shows up on site with a computer and khakis and a clean vest, where everybody just goes, "Oh, act busy." You want them to know that. Like, I'm fond of saying, like, I'm not here to shoot your holes full of job or shoot your job full of holes. Excuse me. we're all on the same page. We're just trying to build a better mousetrap. We're all on the same team, and having a cooperative relationship rather than you don't want them hiding stuff. You don't want them lying to you. You don't want them saying, "Oh, let me check," and then not getting back to you. You want them to understand that you're really all on the same team. They might see you only once a month or so, but you want to make clear that it's like, yeah, okay, I work for the owner, but I'm not here. I'm not trying to make things harder for you. I'm trying to make things easier for you and everybody else.
Yep. So, getting into some fun information, we'll talk about the future of low voltage integration and some trending smart technologies. One of the things that I think of the most when I think of some trending technology is BAS. They've gotten so much more advanced in the last 10 years than they were before. They've been well optimized, and I feel like they'll keep getting optimized. They're integrating more pieces of equipment into the BAS. So where it used to be just air handling units, it is fans, dampers, low voltage systems, some electrical equipment. They're able to see everything on there. I've had one project where they were able to control lighting from the BAS. These technologies with BAS are important to keeping that integration going and maintaining a unified single smart system in a facility. Going back to integration improvements, having that interconnectivity between access control, nurse call, fire alarm, lighting control, RTLS is diamonds you never thought about before 20 years, and here they are. And it's just going to keep going that way as more technology improves. Wireless technology is a big thing that we're seeing now, where you're able to control the BAS or lighting control from a smartphone or an iPad. The maintenance guys no longer have to go into the job site to look at their air handling unit. They can do it from their phone on the couch. There's some wireless technology still with nurse call that can still be improved for maybe some HIPAA information being sent to doctors securely and safely, so that from home or from their office, or if they're tied up with another patient, they're able to keep track of their other patients and monitor them and make sure that everybody is as healthy as they can be. One example that I like to talk about is the IIT Innovation Center in Illinois. They've got a great integration between lighting control and architectural integration that I've never seen before. If you can look at this picture, those windows up on the upper floors are actually mesh plastic screens that are able to, through HVAC, are able to expand like a pillow or contract to let light in or keep light from coming in. This helps, kind of like daylight harvesting, to mitigate the use of energy and electricity when you can use daylight as a source of light in the space. That keeps everything very open and very high efficiency.
Oh, this is the fun part.
Yeah.
All right, so what can we expect to see in the future? This is one of the things that we're trying to advocate here is, in addition to knowing the job that you're working on or knowing the projects that you've already worked on, we think it's wise to stay up to date with trends in these low voltage systems, especially for healthcare, because it's on a fast trajectory and it changes quickly. And what will make you individually stand out, perhaps as a more attractive commissioning authority or client goes, that is kind of weird. How would you handle this? Is open up your pre-written test script and try to divine an answer to that question there, then it's probably not going to be the most beneficial exchange for your client. So we're going to take a few minutes to talk about some emerging technologies. Some of them are already out there and fairly common. You may have seen some of these out there now, even though they're fairly new, but some of them are only one step past speculative. So as communication technologies evolve, as the commissioning industry evolves, Staying up to date is going to be critical, and these new integrations are going to appear, and commissioning authorities are going to be tasked with writing commissioning plans to demonstrate them. Commissioning agents in the field are going to be required to have broad knowledge and deep expertise, and will benefit from understanding these trends and emerging integrations. For access control, for example, facial recognition, that's a thing. It's not very common for opening up doors in a hospital now, but everybody's phone in their pocket can do it and do it pretty well. Biometrics used to be just a thing of sci-fi movies, and they're getting more and more common. They used to just use biometrics for the most sensitive of spaces, but you're starting to see them now where it's not that sensitive. They just really want to make sure. But it's not so expensive now that it's a deal breaker, and you can only use it in one space. And this is one of my favorite examples. I've been talking with Rebecca about it for days, so forgive me for doing it again, Rebecca. But it's a great example of how quickly this stuff can move. So here we are in April 2021, about a year since people first heard the phrase COVID-19. Right now, you can get access control systems that are health conditional. It's still just a key, but it also puts a dot on your forehead and it won't unlock the door if you have fever. There are CCTV systems right now in play that facility managers can go and buy and have installed that can detect mask compliance. If you're not wearing a mask, it'll flag you and put a flag on your badge, or it won't unlock a door for you. There are systems right now that will do what's called radius monitoring, that will continually monitor in your facility the distance between your name badge and everybody else's name badge, so they can log and track and trend whether people are in the facility. And those exist right now. They're pretty new, but that was just a year ago. In a year, it went from virtually zero to hero, and now a new hospital can buy those and have them installed right now. Nurse call systems. I won't be surprised if pretty soon health information gets transmitted with a nurse call to a portable device. Predictive nurse call might use an algorithm and detect abnormal environmental conditions or unexpected patient activity, or even just predict patient needs from call history trending, and like, yeah, that person, 90% of the time within this 5-minute window, this person's gonna put in a water call for a glass of water, and maybe a nurse can swing by and get that taken care of before the button gets hit. Fire alarm systems, there are some really advanced video fire detectors that just use a camera in lieu of a smoke or a heat detector, that just uses deep learning artificial intelligence to detect a fire strictly from the appearance of some video in like some engineering space that's crowded. It has lots of visual obstacles, and a smoke detector might have told the system, there's a fire in this room, but it may not be very good at telling a person exactly where it is, where this video system can bring emergency responders exactly to the fire. And audible exit marking. I haven't seen one of these in the field yet. It seems pretty simple, but I love the idea, and I haven't seen one yet. It's where just little noisemakers might be at the exits. And it's one thing to have an exit sign, but if you're crawling on your belly through a corridor full of black smoke, it might be nice just to have a little dinger down the hallway guiding you to your egress path.
Yeah, those are game-changing technologies that can improve life and keep death counts down. And having, especially tying into COVID, these situations that are universal really inspire technology upgrades. And a lot of these technologies come as a result of high problems that are common throughout the facility, like pandemics and things like that.
Right. Yeah, that was a wake-up call.
Yeah, exactly.
So while many of these low voltage and communication systems, especially in healthcare, but almost anywhere, while many of them are
We
always
also have lighting control. I don't know if you mentioned that.
I did not. Oh, did I miss lighting control?
Yeah.
I did. All right. Sorry about that, everybody.
You're fine.
So as
lighting
new research is performed on the impact that lighting has on patient outcomes, we can fully expect that healthcare lighting control systems are going to evolve as well. And traditional commissioning methodologies for these systems may expand to include, field verification of much more complex and detailed sequences than just energy conservation alone.
Yeah, from what we can tell right now, that advancement in lighting control is based on comfort and quality. So I don't know if you guys remember the early stages of occupancy and vacancy sensors, but it was almost better to not have them. The occupancy sensors would turn off in the middle of a class project, and everybody would be waving their hands around to try to get the lights to come back on. That's definitely improved in the past, and now we have good quality occupancy sensors that can even tell based on the clicking of your keyboard if you're still in the room. I think the future of lighting control is going to be comfort-based, so there's going to be a lot more of that automation and making sure that you don't have to turn the lights on or off when leaving the room, that it knows that at the end of the day you might want a dimmer light, or in the middle of the day, they have daylight harvesting, but you might want a lighter level or a dimmer level based on how awake you are. So these are some trends that we can start to see in lighting control that will definitely be progressing further and further as time goes on.
Yeah. And it'll be pretty cool, I promise.
Yeah.
So while most of these systems are going to remain discrete, just so that one system failing doesn't mean the whole facility goes down, the integration between all these individual systems is always going to be a critical feature. And one of the most important things that low voltage systems can do in a hospital is communicate together for performance of the facility and safety of the occupants, safety of the staff, safety of the patients. And as more modern technologies become available, the interconnectivity between these systems is only going to become more complex and require more detailed testing in the field during the acceptance phase. And understanding these systems and staying on top of healthcare technology trends, keeping your finger on that pulse, staying aware of what's going on in system development, we are going to help commissioning authorities secure more work, do that work better, and be better advocates for our clients, which is the name of the game. Rebecca, do you have anything else for me?
I think that's it. Thank you for giving us your expertise on low voltage systems. I hope that we provided the people listening to this video some good information about low voltage systems, about how we test them, about their integrations, about some common issues that we've seen in the field and ways to mitigate those issues, and some smart technology, some things that we see in the future and things that we should all, as commissioning agents and clients and subcontractors, start getting excited about.
All right, me too. Thanks, everybody.
Thanks.